So, what is push-down automata? A push-down automata is a way to implement a context-free grammar in a similar way we design DFA for a regular grammar. A DFA can remember finite amount of information, but PDA can remember an infinite amount of information. The term push down refers to the stack of tray which can be pushed down so that we can add more tray into it, like a tray dispenser at a cafeteria. The computation starts with input string and an empty stack as shown in the diagram. In simpler words, it uses before concept, which is the last element that go in is the one who go out first. The stack operation only affects the top of the stack and has two operations. So, how do we interpret the equation from the state diagram? The first equation shows when you need to replace the input in a stack. Second equation shows when you need to push the input into the stack. Capital Q show our state, which in this case is three states, Q0, Q1 and Q2. Next, we have input alphabet of A and B. Our stack alphabet here is capital A and our initial state is Q0. Finally, we have Q2 as final state. This is our transition table. First, draw all the states and circle them. Then, double the circle for the final state, which in this case is Q2. Draw arrow to Q0 as it is the initial state. The first equation shows us Q0 moves to Q0 itself. So, draw a loop circle to Q0. Write input A, pop lambda, push capital A. Next equation move from Q0 to Q1. So, write input B, pop A, push lambda. The third equation move from Q1 to Q1 itself. So now we draw again loop circle back to Q1. Do the same for the other based on the equation itself. As an example, we got input string of A, B, B. So let's create our state. First, we start with the first stage, which is Q0. First input is A, so we use this equation. As you can see in this equation, when our input is A, we will pop lambda. Lambda indicates whatever element in it or it is empty, we can push our capital A into the stack. Let's move on to the second input, which is A also, and we still in Q0 state. So we will use the same equation as before. Here, since our input is A and we don't care what element in our stack, we can push our capital A into the stack. So now we have two capital A in the stack. The third input is B. Once again, since we still in Q0 state, we will use this equation. In this equation, if our input is B and our top stack is capital A, we have to pop or remove the capital A from the stack. Then we move to Q1 state. For the last input, which is B, we will use the equation at the Q1 state. So, we can pop the capital A from the top stack. Now, our stack is back to empty and our final state is Q2. Since we fulfill the condition, the string input of A, B, B is accepted.